Hello and welcome to today's lecture. In this lecture, we're going over 3 different examples. In these examples, we're going to experiment with if-else structure and try to learn if-else structure better. Let's jump into Visual Studio. So in the first example, I'm going to ask the user to input a number and we calculate the square root of that number for the user. But you have to note that we cannot just take any number from the user. We don't want to get negative number. If we get negative number, we wanted to prompt the user that you have to enter a positive number. So in order to be able to calculate the square root, I'll include math library. And inside the body of the code, I'll introduce a float number. var1, and I'll initialize it with 0. Here I print in a statement and ask the user to enter a number. Please enter a float number. And then I'll scan that number. I'll scanning it using %f and I'll store it in the memory address of variable var1. Now in order to calculate the square root is just, I'll go back and then introduce another variable, float sqrt ret, which is short for return. Sqrt return is equal to square root of var1. So this code is correct. This will work, but if your user input a negative number, everything will be ruined. Let's compile and run this code. I would put Ctrl F5, enter a number, I'll put -4. Okay, so now let's debug it to see what will happen to the square return when we input -4. Now start debugging. I'll enter -4, and now we're back here. So right now, the square return is the value var1 is -4, and the square return is something weird because we just created the number and we haven't calculated it, because when the yellow flash is at line 12, it means line 12 hasn't been executed yet. If I jump over that line, you see the square return is -nan. And this number is not identified for C. C cannot calculate the square root of a negative number. So if I write a good code, I have to prompt the user that you have entered a negative number and you have to enter a positive number. So what I would do, I'll exit debugging mode and create an if statement. If var1 is less than 0, I want to create a print statement. Please enter a positive float number. /n to go to the next line. And then else, it means if the actual number that user put was positive, I just wanted to calculate the square root. And I wanted to set the sqrt return to 0 if the return was so I'll just calculate the square root of var1 at else statement, and then I'll print the result using printf statement. The square root of %f is %f instead of the and slash n to go to the next line. Instead of the first %f, I'm going to print var1. Instead of the second %f, I'm going to print sqrt return. So let's compile and run the code. First, let's debug it. Let's enter a number. If I put -4, please enter a positive number. And the code ends, oh, I forgot to put any breakpoints. Let's put a breakpoint here. Debug, start debugging. If I put -4, so we are at line 12. So the condition, which is var1 less than 0, is true. So if I click step over, it will go inside the body of this if condition, and it will execute the line, please enter a positive number. And if I click step over, it will go to the end of the curly bracket and then to the return. So the else part would not be executed at all. And if you look at the console window, please enter a positive number has been appeared on the screen. So now let's restart the program. This time I'll input 4. Now we're at line 12. This time this condition is false. So if I click a step over, we'll go to the else statement. And the else statement, the first part is to calculate the square root. If I step over, the square root will be 2, which is correct. And if I step over that line, the statement will be printed on the screen. And as you can see, the square root of 4 is 2. Awesome. In this example, we're going to take two numbers in a friction, the numerator and denominator, from the user and calculate the result of that friction. We need to be careful that we don't accept division by 0. Let's jump to the code and start writing the example. So in this example, we're going to calculate the fraction of two numbers, numerator and denominator. So I'll start the code by declaring two float numbers, one n for numerator and one d for denominator. I need to declare another variable to store the result. I'll just name it result. In the next line, I'm going to print f to prompt the user. Oh. The good thing with Visual Studio is if you have a typo in the name of your functions, for example, the one I had in printf, it will not turn color. Now, when I fixed it, the printf turned blue. It means that I recognize this function. So please enter the numerator. And then I'll scan f the numerator using %f for float, and as the argument, I'll put the address of n. So in the next step, I'll print f, please, uppercase P, please enter the denominator. And scanf -s using the format %f, and I'll store it to the address of variable d. So now the result would be n divided by d. So the result will be n divided by d. If I put the breaking point at n divided by d and start debugging the code by pressing F5, it asks me to enter the denominator. If I enter 1, it asks me to enter the denominator. If I enter 2, so we'll be stopped at result. So you see that n is 1, d is 2, and result is a weird number. And that's because we have only declared result and we haven't actually calculated or initialized it. So if I step over or press F10, step over, you see that the result will change to 0.5. It means that the result is calculated. But let's restart the debugging. And now I wanted to put denominator as 0. So if you can see, d is 0, n is 1, and if I step over the result would be infinite. So I want to be able to prompt the user that if they enter 0, 0 is the division by 0, and we need to do something else. So here I'll create an if statement and say if d is equal to 0, and if that statement was true, I want to print f and tell the user that division by 0 has occurred. And else, if d wasn't 0, I want to calculate the result and output the result. Print f %f divided by %f is equal to %f. And as the arguments, the first argument is n, the second argument is d, and the last argument is result. So if we clear this breaking point and put the breaking point on line 12 and restart debugging, okay, there was wrong with my printf function. Yes, I forgot a t. If I press F5, debugging starts, numerator 1, denominator 0. Okay, so this condition is true. If I step over, I'll go, and the code block for if condition will be executed. So I'm here at printf function. If I step over this printf, the printf statement should be printed on the screen, which is division by 0. And if I step over that, we'll go into the end of the code. Let's restart the code, and this time I'll put numerator as 1 and denominator as 2, for example. And now d is 2, n is 1, and if I step over line 12, I'll go to else condition because the condition is not satisfied. The result of d equal to 0 is false. And then if I step over the result line, the result will be calculated. And if I step over the printf line, the printf will be printed on the screen. And as you can see, 1 divided by 2 is equal to 0.5. In this example, we're going to work on a problem that we ask the user to input the temperature, and we compare the temperature to see if the weather is cold, nice, or hot. If the temperature was less than 20, the weather is cold. If the temperature is between 20 to 30, it means the weather is nice. And if the temperature is bigger than 30, it means the weather is hot. Okay, so let's start by declaring an integer called temp for temperature. And then I'm going to prompt the user. Please enter the temperature. And then I'll scan the temperature. So now we read the temperature. We need to decide on if the weather is cold, nice, or hot. Okay, if temp is less than 20, we need to return that the weather is cold. So I'll just print F. The weather is cold. So now I wanted to check if temp is between 20 to 30. We already checked if temp is less than 20. So if I, in my else if statement, if I say temp is less than 30, it means that if I am here, it means that temp is greater than 20. Now I'm checking if temp to see if temp is between 20 to 30. And then on the next line, I'll create a curly bracket for the else if condition, and I'll print the weather is nice. And if the weather is not less than 20 and it's not less than 30, it means it's equal or greater than 30. So the weather is hot. Then I'll introduce the else condition. And in else condition, I'll have a printf statement. And the weather is hot. So let's review the code. If the temperature is less than 20, the first block will be executed. If the temperature is less than 30, the second block will be executed. And else, which is temperature being equal or greater than 30, the third block will be executed. I don't need to specify temp between 20 to 30 in the second condition, because if I'm in the second condition, it means the first condition is already rejected. So it means that temp is greater or equal than to 20 that I'm here at line 19. So let's put a breakpoint at line 15 and debug the code. Go to debug, start debugging. Okay, I see an error here, used uninitialized memory temp. If I go back to my code, okay, I scanned %d and put it in temp. And I'm being asked why temp is not initialized. The error is temp being not initialized, but the error has more into it. Let's look at the error. Scanf Formatting %d requires an argument of type in %. It's basically saying I need an address, not a variable, and I feed it, and I put the temp variable as in the scanf, not %. If I put the %, everything would be fixed and the code would be compiled. Okay, the code is compiled. Now the debugging process will start. If I input the temperature as 15, you would see that first the code will be executed until line 15, which is the breaking point. If I step over this line, we will go to the block of the code for this condition. And if you look at temp, if I hover my mouse on temp, it said temp is 15, and 15 is less than 20, so that's true. And if I step over the printf, the print statement, the weather is cold will be printed on a screen. And if I step over that, we will be going to the end of the code, so none of the other blocks of the code will be executed. If I restart debugging, and enter the temperature to be 20, now the first is wrong because 20 is not less than 20. If I step over, we'll be jumped to the next condition, which is at line 19. In this condition, this one is true because 20 is less than 30. If I step over, we'll go to the body of this if a statement, and printf the weather is nice will be executed, and as you can see, the weather is nice is being printed out. And I can restart the code. And this time enter 35. And if I step over, we'll go to the next condition, and this condition is also wrong because 35 is not less than 30. We'll go to the next condition, which is else. And in this case, the weather is hot will be printed if I step over the printf function. And as you can see, the weather is hot. It's being printed here. So we have learned about the concept of nested if-else structure. Let's see if we can have a nested solution to this problem as well. So you see that I checked temperature against 20, and then else I can compare it with 30, and if it's not less than 30, then it means that it's bigger than 30. So all this else could move into curly brackets. So else, and I can have another kind of if, because if I'm here, if I'm in these lines, if these lines are being executed, means that temp is equal or greater than 20. So now I'll check it against 30. And if it was less than 30, I will say the weather is nice. And else will be the situation that temp less than 30 is not true, which means temperature is bigger than 30, so I will print the weather is hot. So I don't need these codes anymore. So now I used the concept of nested if-else condition to put an else-if statement inside the else statement we had. So if we are in the body of this else statement, it means that temp is equal or greater than 20. And then I'll check the temp against 30. And if it's less than 30, I'll print nice. It means that it's between 20 and 30. And if it's not, it means that it's equal or greater than 30. And I'll print the weather is hot. That concludes our video for today. Thank you for watching, guys. I hope that by practicing these examples, you can master if and else structure. But if you have any question, don't hesitate to send me an email or text me on Microsoft Teams. Have a good day and see you in the next episode.